Good morning to everyone. I'm Valentina Catanzaro from University of Salento, and I'm going to explain the main results of the work entitled Impact of Dust Outbreaks on Particle Mass Concentration at the Surface during the COVID-19 lockdown measures over southeastern Italy. The main objectives of our work is to investigate, first of all, the impact of lockdown measures over air quality at two different sites of southeastern Italy that are very different from each other. One is an urban traffic site and the other is a rural background site. More in specific, we wanted to analyze the impact of the lockdown measures on two parameters, the PM2.5 and the PM10 mass concentration. And at the end, we wanted to identify dust events and to study their impact on PM10 and PM2.5 mass concentration during the investigated periods. The COVID-19 lockdown measures in Italy started the 9th March 2020 and ended the 18th May 2020. During this period, all non-essential industrial production activities were suspended and was also forbidden to move outside the place of residence. We wanted to analyze two sites of Lecce. One is Lecce Libertini, which is a square in the center of the city and is affected from human activities such as traffic, domestic heat, and also industrial activities. So we have identified this site as an urban traffic monitoring area. The other one is Cerrate, which is far from the city center, and it is surrounded by the sea. So in this case, we have identified this site as a rural and a background area. We have used the Apulia Region Air Quality Agency data. The monitoring station is composed by a SWAM dual-channel instrument that can analyze the mass concentration of the tested parameters such as PM2.5 and PM10. In order to analyze the effect of lockdown, we firstly have studied the changes of mass concentration of PM10 and PM2.5 in both sites. We can see that these two parameters have the same trend in Libertini and in Cerrate. So we can see that there is a decrease of mass concentration starting from the lockdown period. The study area is also affected not only from local sources, but also from long-range transports. For example, there are aerosol sources from the north and the east of Europe, also from the Mediterranean Sea, and also from the Saharan Desert. So a preliminary analysis have shown that during the period of lockdown, Saharan dust affected the southeastern Italy. And we have listed those days. We have identified them using two models. The first one is based on forecasts, and the other one is based on back trajectory. This in order to identify the origin of the air masses. Here we have an example of the 17th of May 2020, as you can see. From those two pictures, you can see that in this day there was a dust outbreak. We have studied the percentage reduction between the pre-lockdown and the post-lockdown period in Libertini, which I just said that is an urban traffic site. We can see that there is a significant reduction in the post-lockdown box plot, both from PM10 and PM2.5. This reduction for PM10 is about 30%, and for PM2.5 is about 39%. This because this site is more affected by fine particles derived from anthropogenic activities. So we have a more visible decrease of PM10 of PM2.5 mass concentration instead of the PM10. We have made the same work for Cerrate, that is a rural background site, and we can see that the mass concentration of the two tested parameters follow the same trend of the urban traffic site, but we can see that the mass concentration reductions are smaller. The most significant one is for the PM2.5, which has a reduction of the 25.2%. And also PM10 has a reduction that is about 11%. I also want to remember that this rural background site is far from anthropogenic activities, so the quartz fraction is dominant. Then we have made the average percent departure. We have made a comparison between the reference year that refers to the average daily concentration of the 3 years before the 2020, so 2017, 2018, and 2019, and we have compared them with the average of daily mean values of the 2020. And we have found that the most significant reduction is in the post-lockdown period, in particular in June. So the largest decrease, for example, of PM10 started in June and lasted up at about October. The same trend follows the PM2.5, but the decrease of APD is more relevant because in this side, a larger contribution of fine particle is observed, as I just said. So we have a reduction in June of the 38% for the PM2.5, and also in June for PM10, we have a reduction of the 33% in the post-lockdown period. The rural background site follows the same trend. We have that the PM10 and PM2.5 mass concentration decrease as the urban traffic site, but in this site the APD percent was less marked. Since on average is less affected by anthropogenic activities. Here we have a reduction of the PM2.5 of 37% in June and lasted up since October. And at the same time, the PM10 shows a reduction in June of the 35%. So also in this case, the reduction is observed in the post-lockdown period. Then we have the box plot that refers to the dust, refers to the comparison of the dust events and the days which not included the dust events. Actually, as I just said, one of the most important objective was to analyze the effect of dust outbreaks over the study area. And the comparison between the two data sets, the first containing the dust event and the second from which the dust days have been removed, shows that the Saharan dust had an important and a significant effect on the PM10 mass concentration. If we excluded those days during the lockdown period, the PM10 and the PM2.5 mass concentration, the reduction increased of the 18 and 3.6% respectively. So we can see that the mean values, for example, of PM10 during the lockdown period, if we consider the dusty days, is about 22.2 mass concentration, while if we excluded the dusty days, is about 18.2. Also, the rural background site have a significant reduction of PM10 mass concentration if we wanted to consider the no dusty days. This site actually is less exposed to fine particles. We have a reduction of the 30% of mass concentration of the PM10 if we excluded the dusty days from the data set. Also here we have again calculated the APD, and we can see that the Saharan dust particles affected more the PM10, and we can see from the graphic that we have a lower APD decrease for PM2.5 particles compared to the PM10, just because in the Libertini area, PM10 2.5 particles are less affected and influenced by dust events. We have that in March for the PM10, we have a reduction of the 24%, while for PM2.5, we have a reduction of the 4%. Also, for the background and rural site Cerrate, the Saharan dust particles affected the quartz fraction more than the PM2.5, in accordance of the characteristic of the site. We have a reduction in March, so during the period of lockdown, of the 27% for the PM10, while for the PM2.5, we have a reduction of the 6% just in March. The impact of dust was absent in April in both sites. So in conclusion, we can summarize our result into 3 points. We have compared 2 different sites. The first one, the urban traffic, affected firstly from anthropogenic activities, such as, and human activities, such as traffic, domestic heat, and also industrial activities, while the rural background site is far from the city center and is very, very close to the sea. So we can say that the lockdown measures had a significant effect on fine particles on both sides because of the of the absence of anthropogenic activities. The most significant reduction for PM2.5 mass concentration was observed in the period after the lockdown measures in both sites, and the reduction is equal to 39% for urban traffic, while the reduction for the rural background was about 25%. The dust events, on the opposite, influenced the quartz fraction, so the PM10 fraction, in both sites during the lockdown. Once that we have identified and then we have excluded those dusty days in the period of examination, we have seen that there is a significant reduction of PM10, of the 18 and the 30% of mass concentration in Libertini, which is the urban traffic site, and Cerrate, which is the rural background. Finally, the 2 sites had been affected differently by lockdown measures and dust outbreaks. The urban traffic site is more sensitive to fine particles, just because of the human sources, while the rural background area is more influenced by quartz fraction because it is far from the city center, I just said. Thank you for your attention.
Okay, Valentina. Thank you for your presentation. There are questions? Good. our question. I have a question for you. A curiosity. Are you a dataset also for finer fraction, PM1, for example?
Good morning to everyone. Thank you for the question. No, we did not include the ultrafine mode because we obtained this data from ARPA Puglia, and ARPA Puglia provided only PM10, PM2.5 and gases.
Okay, thanks.
Thank you.
Okay. A question from chat by Tomasek, Ines. Are you considering to repeat the measurement post-lockdown now that we are back to work? It seems more people are going by car to work.
Yes, now we are considering the 2021 effect on air quality, just because we start again to go to work with our car. Industrial activity also started again. So yes, we are going to consider the measurement of the post-lockdown period.
Okay. Thank you. Okay, I can proceed with the next presentation in remote mode of Nabil Deabji that will present mineral dust influence on the background aerosol chemical composition in Northern Africa at high altitude.
Hello everyone and welcome to my presentation for the Atmospheric Dust Conference. I'm really happy today to present the main results from the Atlas side, but the topic will focus on the background aerosol chemical composition and source influences, especially mineral dust. So during the last few years, the measurement at a mountainous site have been of great interest. So the atmospheric monitoring program have been established a substantial number of mountain stations, and this for several reasons. First of all, high altitude sites are really important due to their location far from any anthropogenic emissions. They provide information on the levels, the variability, the trend of trace gases and aerosol in the free troposphere, as well as they allow an assessment of the influence of anthropogenic and natural emission sources. So as a result, high altitude mountains are ideal sites for monitoring the temporal variation of trace gases and aerosols in the troposphere in the background levels. So on this map, we see the distribution of the mountain stations over the world according to their altitude. The stations presented in this study are located at high altitude above 1,500 meters above the sea level. So in total, the map contains 31 stations. Most of them are located in Central Europe and Western North America, and only fewer are available in the Southern Hemisphere. So second, if we look like really the main findings of high altitude sites include source, possible scenarios, and transport pathways. And this previous observation of the long-term transport of pollutants from anthropogenic and biomass burning sources, desert dust, and volcanic plumes from eruption events, we can clearly say that mountain value site can provide an efficient channel favoring the transport of pollutant to the high altitude sites. And if we focus on the African or the Africa area, we find 3 sites previously identified on the map. A site located in the middle Atlas, the Hoga Desert, and exposed to dust transport in the south part of Algeria. So the main measurement carried out are meteorological parameters and gas measurements. The site located in Kenya And their objective is to investigate the biomass burning transport in Eastern Africa. So most of the stations actually study mainly temporal variation of trace gases. The only exception is Izana, which is a site located in the Canary Islands. And well, a big question mark remains concerning the aerosol composition in continental Africa. For this reason, the Atlas Mohammed V, it's an atmospheric research station, was created in 2017 with the collaboration of University of Mohammed V, the CNRS of iCare in Orleans University, and also Tropos Institute in Germany. So the station is located at Mischliefen in the Middle Atlas region with an altitude of 2,000 meters above the sea level in a remote hilly site. The station is surrounded by cedar forests and pasture land that come to life in spring and summer, which is a sharp contrast to the hot, dry climate that surrounds the site, with rich in biodiversity. So the strategic location of the AM5 site, situated at the center of Morocco, not so far from Saharan dust in the south, close to the Atlantic coast, and the left, where the most of the industrial activities happen, in the north of Europe coast and the Mediterranean as well. So the goal of the study is first to quantify and characterize the variability of the atmospheric composition in high altitude, especially in the Middle Atlas region, determine the background inorganic and organic composition of the aerosol particles, and second is to investigate the role of day and night variation, especially concerning regional circulation of the aerosol chemical composition, evaluate the role and the impact of Saharan dust, of PM10 mass concentration, and identify potential sources who could contribute to atmospheric particle concentration, and finally provide new information into the changes in atmospheric composition over time that can be useful for assessing regional air quality and relevant mitigation strategies. And now that we presented the site, we need to take a look how did we collect the samples and what are the different laboratory analyses. So we used a digital day and night protocol sampling 12 hours regime on quartz fiber filters that was frozen and transported later on to Germany. 200 samples were collected from August to December 2017, and different laboratory analyses are shown in the schematic were performed, such as organic, elemental, carbon, trace metal, ionic analysis, hydrocarbons for PAHs and alkanes, and different organic compounds. And different conversion factors were estimated or were used to estimate organic matter, sea salt and non-sea salt sulfate, and the water content of samples was estimated according to the extended aerosol inorganic model. Let's take a look on the results bar right now on the PM10 variation. So we see that PM10 shows PM10 mass shows a strong temporal variation with an average of 29 microgram per cubic meter. Highest concentration was observed during August, while the lowest concentration was recorded in December. So about 145 micrometer as a maximum and 9.6 microgram per cubic meter during winter time. So the monthly variation actually shows really a decreasing trend from August to December, and high concentration were observed during August, which could indicate the presence of dust events during this period. It is important to notice that the typical background PM10 mass concentration in the Middle Atlas region can be defined as a minimum concentration around 10 microgram per cubic meter, which could be stable and representative of periods of little external influence. So the calculation of back trajectories using the high split model allowed the identification of several remote sources of PM10 at the station. We could find 4 main air masses category, which is identified here in the left in the figure. So the first air mass that spent the last 26 hours over the Atlantic Ocean of high altitude above 1,000 meters above sea level is a representative of typical background air mass conditions, which represent 5.3%. We had also 3 other air masses originating from the Atlantic Ocean crossing the coast of Europe, representing 26%, and air masses coming from the Mediterranean and the coast of Europe were the most dominant, about 37% of all samples. And finally, we had air masses originating from the south and eastern Saharan crossing the desert at different altitudes before arriving at the EM5 station and influencing about 22% of all the samples. So if we look closer to the chemical composition, so first starting by the background composition is dominated by inorganic species such as local or resuspended mineral dust, so about around 61%, and the remaining part is dominated by organic matter, but also main ionic components such as sulfate or nitrate. The sea salt remained low due to the distance separated the station from the coast, and the low concentration of EC indicate that the local anthropogenic influence is minimal. But during dust event, the mineral dust contribution reaches 84%, which is a huge impact on the background chemical composition. It is also important to notice that high sulfate was noticed during this period, and we found that there was a correlation between non-C sulfate and also non-C calcium during dust event, which could actually explain the higher concentration of sulfate. The long-range transport of mineral dust has a significant impact on atmospheric and aerosol chemical composition. So the PM10 concentration increased with an increase of mineral dust content, as we can see in the box plot just in the left. And we also we could use the iron aluminum and iron calcium ratios to make distinctions among dust sources, and we noticed that we had higher ratios of iron aluminum during background conditions and lower during dust events. We also noticed an increase of biogenic organic compounds such as biogenic alkanes, which increases during dust event, especially old alkanes such as nonacozan, hentriacozan, or heptacozan, which could indicate that mineral dust had a common source or was loaded with biogenic material around the site. The chemical composition of the organic fraction indicates that there was no strong influence from any anthropogenic sources, which could explain why we had so often higher biogenics than any anthropogenic tracers. So the dust was not influenced by any anthropogenic sources. So the last point of my presentation is to investigate the day and night variation. And we can clearly see that there was an increase of mineral dust during the day due to traffic, and could be related to resuspension of road dust. We had also high organic matter during daytime. Often we saw that there was a slight increase of alkanes, shows that the main source of organics was biogenics, stated previously. We had an increase of EC and heavy metals observed during the evening due to the change of the boundary layer thickness, and finally the difference in concentration between day and night could be explained by an upslope flow resulting from the combination of different transport mechanism in the mountain area. With this, I would like to summarize all the important points that I presented in my talk. So first, I showed you the seasonal variation of the PM10 with higher concentration during summer, especially due to the dust event, and significantly decreased until autumn, winter because of the higher precipitation and less influence from dust, Saharan dust. So I showed you the background chemical composition, which is mainly dominated by road dust, and biogenic materials shown by the high contribution of alkanes. I showed you also what are the different sources influencing the chemical composition, and despite the proximity of the site to the Saharan dust in the south and in the east, the influence of dust represent only 22%, while the marine influence is more significant at 64% from the Atlantic and the Mediterranean Sea. And finally, the day and night time variation of the particles is related to resuspension of road dust during the daytime, and we had an increase of anthropogenic traces such as elemental carbon or anthropogenic metals, mainly due to the boundary layer variation, especially during the nighttime. With this, I want to thank you all for your attention, and I will be glad to answer and to get a feedback from you and to answer any question you have about my results. Thank you all.
Okay, just a moment. Okay. Are there any questions? One question here from participant.
Thank you for these unusual results. My question is, do you have a better idea where these so-called biogenic contributions come from, especially the high molecular alkanes? Are they gas phase or are they particulate phase?
So, good morning, everybody. Nabil is not able to attend because of health reasons to take the questions, so I'm helping him with the questions, the answers to the questions. So we don't have a good idea if it's from the gas phase or it's from the particulate phase, but we believe the measurements were done mostly in the particulate phase. So if it was condensation from the gas phase to the particles, we cannot really tell, but all the results we got was analysis from the particles, from the PM10 particles. We also want to say that actually in the region of the High Atlas, there are a lot of plants, different type of them. And we think maybe it's a conversion, it's a condensation of the gases on the particles that lead to the occurrence of these high molecular weight alkanes. But we don't have evidence at the moment. There are some measurements that were done with the GCMS, and we are still looking at that to see if we can see similar concentrations in the gas phase to be able to actually answer this question effectively.
Okay, another question.
Hello, thank you for the interesting talk. My question also is about the organics again. So I would like to know if you have noticed any oxygenated organics, because you mentioned only about the alkanes. So are there in the particles any oxygenated? Have you had any measurements or indications from the GCMS that there are any oxygenated organics on the particles?
Yes, so the GCMS measurements were not done by us, was done by a partner institution. So I think they found them, but I can't tell you in detail which compounds they found. So, but yes, they found some oxygenated alkanes in the gas phase, but I can't tell you which of them they are. Our measurements were concentrated in the particulate phase, and there we did mostly just a total OCEC characterization and some speciation of these alkanes and ketones. So I can't tell you exactly which oxygenated alkanes were dominant in the samples or species were dominant in the samples.
Okay, thank you very much. Other question on chat bar? I don't see any question. Thank you. Now we proceed with the next talk, entitled How Does It Affect the Health Status of the Population According to the Particle Size Classes of Dust Particles in the Urban Area of an Average City in Romania, that will be presented by Marius Emilian Kovacs.
Hello, my name is Kovacs Marius, and I'm from National Institute for Research and Development in Mine Safety and Protection to Explosion. I will present the papers, How Does It Affect the Health Status of the Population According to the Particle Size Classes of Dust Particle in Urban Area on Average City in Romania. We currently spend a lot of time analyzing the weather forecast or worrying about what food to eat and how they affect our health, but we rarely stop to wonder how the air we breathe affects us. Staying at home or going to the office, we both could expose us to many more unfortunately particles when we could have imagined. Classification of solid particle and particles suspended in air of micronic diameter. As you can see, the house dust and the auto emission has the largest distribution. Environmental protection legislation above prevent the limit value for concentration of suspended particle in the environment. As you can see, the limit value in Romania for PM10 is 15 microgram per cubic meter. The device for determination of dust by particle size classes, it's a Grey Wolf PC4000 optical device. The location of 5 sampling points were in the first stage was in the street DN Mine Road, near Mine Road, DN66, which crossed the city in Petroșani from Romania. Concentration of dust determined in 2 points on 7 particle size class, the percentage related to total dust concentration, TSP, and the value of allowed concentration. As you can see in point 2, the maximum allowed concentration of PM10 dust exceeded in the sample point number 2, and the maximum allowed concentration of PM10 dust It's exceeded in sample point number 3 or so. In another stage of the research, the same determination of dust concentration were performed in the dust measurer in an apartment located on the city Main Street. The result determination are shown in the following. The maximum allowed concentration of PM10 is exceeded in all three cases, analyzed respectively without dust removal operation and with manual and electric vacuum dust removal. Comparison between gravimetric classes of street and house dust. You can see in all cases the concentration is higher in comparison between gravimetric classes of street and house dust. You can see in all cases the house dust is higher than the street dust. The effect of strict micron dust pollution on health population. Direct influence of air pollution on population health consists to change that occur in the body exposed person as a result of their contact with various air pollution. In most cases, direct action of air pollution is the result of interactions of several pollutions simultaneously presented in the atmosphere and only sometimes the action of single pollutant. The OMSE data showed 1 of 9 dead is caused by air pollution. In conclusion, related to the street dust, using the Grey Wolf 4000 high-performance optical device used by Incenex, dust concentration measures were carried out on particle dust, size dust of National Road 66 at 2 points of street dust sample PM10 and total suspended particle of Main Street, point 2 and 3 determined concentration exceeded the value allowed by regulation in force because of more intense road traffic. The maximum percentage of dust concentration on the particle size PM 0.3 and between PM 0.3 and PM10 compared to total suspended particle, it's 28.81% at the sample point 1. Related to apartment dust, the TSP dust concentration is slightly exceeded during the sweeping dust. When using electric vacuum cleaner equipment, the allowed concentration of total suspended has not been exceeded. The percentage of PM 0.3 and PM10 compared to total suspended particle increased from 21% for normal condition to 28.7%. Thank you for your attention. And if there is any question about the article, you can mail me at the following address. Thank you very much.
Okay. Okay, thank you, Marius, for having highlighted the influence on health, on human health of the particle size. And are there any questions? We have 2 questions by the chat. The first one by Rosa Caggiano. Thanks, maybe I miss it, but when and for how long we have sampled? Marius? Maybe he's not online. He isn't online. Okay, okay, we will send the question to the author. Okay, okay. Yeah, but he's not here. The present. Yeah. Ah, okay. Ah, okay.
No, we can't. We have to observe some standards here. Okay, thanks for these unusual results. First is, how did you assure the comparability between the total suspended particle measurements and the PM 0.3 to PM 10? That's the first question. The second one is, you get in the particle size distribution, when I compare 0.3 to PM10, you got a large mass of PM3, 0.3. How do you justify that? And how did you calibrate the gray wolf? I don't know the instrument. My guess is that it is an impactor. If it was an impactor with gravimetric measurement, how did you make sure that larger particles did not jump a stage or two? Because the mass distribution that you get, is highly suspect.
Okay, thank you. Okay, I think we can move to the next talk. Yes, by Tesleem, Olalekan, Kolawole, that will talk about assessment of PM 2.5 and PM 10 pollution around the scrap metal recycling industrial area of Nigeria. Sorry, I have to stop the presentation because there is a mistake. Okay, sorry.
Thank you very much. I appreciate the effort of the organizers in giving me this rare opportunity to present our work. assessment of PM 2.5 and PM 10 pollution around scrap metal recycling industrial area of Nigeria. Is Tesleem Kolawole from Osun State University, Osun State, Nigeria. This work was supported and clearly collaborated with Professor Herman and Dr. Wadinya Fomba, both of the Institute of Leibniz Institute of Tropospheric Research, Leipzig, Germany, and other colleagues from Nigeria. As we all are aware that particulate matter pollution is a major global concern because it affects the health of human beings. And recently in 2019, the Health Effect Institute reported that 4.4 million people died globally as a result of long-time exposure to PM 2.5. As we all know that the source of PM 2.5 could be geogenic or anthropogenic. Mainly anthropogenic contributions coming from industrial emission, traffic emission, waste incineration, and so on and so forth. And this could cause health implication on human beings. In Nigeria, there is enormous demand for metals, and because of that, metal recycling plants or factories were built in Nigeria. And the source of this, the major material for this factory is metal scrap metal materials that are used in order to produce steel. And this has caused a lot of havoc or pollution in the environment because where they are located, they are not well planned and no mitigation to abate such pollution in our environment. So this work look at the assessment of PM 2.5 pollution and scrap metal colony, and the objectives are as follows: determination of mass concentration of both PM 2.5 and PM 10, water soluble ions in both particle fraction, to also determine carbohydrates, sugar content of the particulate matter content of the PMs, and also to determine the sources of these pollutants. Sampling site and analysis. Like I said earlier, that a lot of metal recycling factories were built in Nigeria in order to make up for the demands of non-ferrous and ferrous materials in Nigeria. The study area has the highest number of metal recycling plants we have in Nigeria. And the reason being that the area where this metal are located has a gas pipeline, and the gas pipeline is usually used as a source of electricity in order to power the electric furnace where the metal processes are being carried out. Apart from the metal recycling plants located in this area, there are some other manufacturing factories such as cement factory and petrochemical depots are also located in this area. In other words, this area has a lot of pollution sources that could affect the environment. 2 decades ago, when manufacturing better recycling manufacturing plants were located in this area, the area is more or less an rural area where we have scanty population there. But now it's been populated, it's turned to urban center because those factories really brought a lot of investment, so that attracts urbanization in this area. And this has consequences. There's a lot of consequences. Next slide is sample collection. This work was carried out. So sampling was carried out in this area in order to monitor the air pollution in this area. So low volume sampler was used. Double stage giant stack sampler was used, and this contains 2 major components: the pump and the sample collector. Detail of this, the process or detail of this the process can be found in Marhot et al. 1993. The sampler is a low volume sampler, has 2 stages, contains a fine and the coarse stage. The fine corresponds to the PM2.5 stage, while the coarse stage corresponds to PM10. The samples were collected by gravimetric analysis on pre-weighed and preconditioned polycarbonate nuclear pore filters, which is 47 millimeter in diameter. Sample duration was for 24 hours during the wet season, as a period of October 2020, and in dry season, that was March 2021. The sample collection was done in a week, was carried out in a week in both seasons. Then the filter was now analyzed for its elemental components, water-soluble components, water-soluble ion components, and also the sugar content. TXRF was used to analyze for metals, and prior to this analysis, 4.4 millimeter, which corresponds to 1% of the nucleus of the filter, were punched out and were placed on TXRF's sample holder substrate. After which HNO3 was added to the filter, and also the gallium yttrium also which serve as interactant that was also added. The solution was left to evaporate at 100 degrees Celsius, and thereafter the substrate containing the particles on the foils were measured. Details of this sample preparation can be found in Humba et al. 2013. Also, ion chromatographic techniques was also used in order to determine water-soluble ions. Filter were extracted. 25% of the filter was extracted with 30 ml molecule water. The extract was shaken via shaken, and sample extract were filtered through 0.45 microns one-way syringe filter to remove insoluble material prior to ion analysis. The analysis was performed for cations such as sodium ion, ammonium, potassium ion, magnesium ion, calcium ion, while the anions constitute chloride ions, sulfates, and so on and so forth. The mass concentration of PM 2.5 PM10. This slide showed the time series of mass concentration of PM 2.5 and PM10 in both wet season and dry season. And it was observed that the highest concentration was observed in the dry season for both PM 2.5 and PM10. However, daily PM 2.5 average did not exceed the 24 hours World Health Organization air quality guideline in the wet season, while in the dry season, they exceeded air quality guidelines in the dry season, both for both PM 2.5 and PM10. Also, the average percentage fraction of PM 2.5 in the wet season and the dry season for this study were 1/4 of the total sample analyzed. Meanwhile, the PMs are mainly sourced from industrial and other anthropogenic and fugitive dust from soil. Our results is also compared with previous work, especially the work that is germane to this work. There is similarity between our work, especially in the dry season, PM10, similar to the work of Zora et al. 2020 in Milan, and also Chu et al. 2012 in Taiwan. Yeah. When this work is compared to the work of Owede et al. 2019 and Owede et al. 2009, let's realize that our value or result is comparatively low compared to Owede 2015 and 2009. However, the result of our work is far higher compared to the Zhang et al. 2018 and Fomba et al. 2019. Water-soluble ion. The result of water-soluble ion shows seasonal variation in both anion and cation in both seasons. They are comparatively, the water-soluble ion in dry season is higher compared to the water-soluble ion in the wet season. There are correlation between most of the anion and the cations and some prominent metals. They have almost linear regression. We compare sulfates to sodium ion. And of course, nitrogen to sodium ion, you have linear regression. And this indicates that nitrate and sulfate salt are used. Nitrate and sulfate salt are used in foundries, in manufacturing both ferrous and non-ferrous metal. Therefore, the presence is as a result of MRF processes. Then also carbohydrates, so sugar, there's a variation, there's a seasonal variation between sugar. There's a strong positive correlation between levoglucosan and potassium ion. There is somewhat linear regression between levoglucosan and potassium ion. The presence of levoglucosan is an indication of biomass bonding in the study area. Elemental distribution. Also, there is significant variation between PM 2.5 and PM10 in both seasons. And utmost importance, the concentration of iron, zinc, lead, plus potassium and calcium. Concentration of potassium and calcium. They are the most prominent metal in that area. And the reason is not far-fetched, because lead is, of course, lead, zinc, and lead and zinc, they are alloy metals. That's when their base melts, they have very low boiling point and they expand. So after all, now look at the concentration of lead, iron, zinc, and calcium in that area. Look at the time series to compare this result, and it was realized that these metals are very higher in rainy season than dry season, and PM 2.5 and PM 10 is also higher than PM 2.5 in all these prominent metals. Also, there are positive, very strong positive correlation between all the metals, and this is an indication that from the same source. Similarly, as linear regression between manganese and iron, which is as a result of could be as a result of cluster relationship or cluster source, and in the case of lead and zinc, it's as a result of anthropogenic sources. Principal component analysis was also performed in order to classify the metals so as to know their sources. 3 factors were identified. Factor 1, composed of potassium, calcium, titanium, manganese, iron, zinc, copper, nickel, and hafnium. And their PC load is between 0.66 and 0.94. And of course, we have weak load of lead, which is 0.56. And their presence is attributed to alloying materials and expanded pins that normally becomes volatile during melting processes. And of course, selenium and molybdenum. And this could be as a result of fossil fuel combustion in that area. While factor 3 are solitary element, which is strontium, which is ascribed to dust emitted from cement factory in the study area. Thank you very much.
Thank you very much to Tesleem. Are there any questions from participants? Any question? No? I don't see question on the chat bar. Okay, thank you, Tesleem. We can start.
You're welcome. Thank you very much.
Thank you too. Okay, we can end the first lot of presentation with the Oriol Teixido that will talk us on the impact of dust aerosol on air quality during COVID-19 lockdown in Abu Dhabi.
Between the Environment Agency Abu Dhabi and Khalifa University in Abu Dhabi. My name is Oriol Teixido, and we will be presenting with my colleague Dr. Diana Francis from Khalifa University. So, first of all, we wanted to give you an introduction about Abu Dhabi Emirate. Abu Dhabi Emirate is the capital emirate of the United Arab Emirates, and we are in the Arabian Gulf region. Abu Dhabi covers 85% of the area of the United Arab Emirates. And it's important to know that the climate in Abu Dhabi is arid, with a subtropical climate that is hot in summers and mild to cool in winters with sporadic rainfall. Also, in Abu Dhabi, we have varied geology. So we have from mountains rising up to 2,000 meters in the east. We have also sandy desert, wadis, and salt flag lakes. About us, myself, I'm working for the Environment Agency Abu Dhabi. This is a government entity, and we are the Middle East largest environmental regulator with strong focus on protecting and enhancing air quality, groundwater, and the biodiversity of Abu Dhabi desert and marine ecosystems. And with us, we also have Khalifa University and the NGOs lab, which is the Environmental and Geophysical Sciences Lab, dedicated to the study of the environment and the climate. During last year, we know that many changes have happened around the world, and some of them have impacted largely the environment and have impacted the air quality in Abu Dhabi. So first, we wanted to explain which have been the major changes during the COVID-19 in Abu Dhabi. Of course, the largest change was in the transport sector. Here in Abu Dhabi, in mid-March, there was scheduled a lockdown, which reduced mobility in all the sectors for around 40%. After the COVID measures were a little bit eased in the end of June, and this led to a recovery of the transport. In the energy sector, especially, we saw a small reduction also during the same time period, especially for the electricity generation and water desalination. And in the industry, we did not see any major operational changes in 2020. However, we saw a small lower of the emissions compared to the previous years. So these changes on the socio-economic activities, they had a direct impact also on the air pollution in Abu Dhabi Emirate. In the Environment Agency Abu Dhabi, we currently have a large network of 20 air quality stations, and we wanted to know which was the impact of these changes on the air quality. The first thing that we saw is that during the same time period that we had lockdown, there was a large decrease on the concentrations of gas pollutants in Abu Dhabi Emirate. In this graph, we are showing just as an example of the nitrogen dioxide over all our stations, and we can see that once the lockdown started, there was a large decrease. This decrease is approximately around 40% when we compare these concentrations to the concentrations we had before lockdown or we had with previous years. Similar reductions we can see also for other gas pollutants like benzene, CO, SO2, and ozone when we compare it with previous years. The same analysis that we did using our ground measurement stations, we did it checking with the satellite information that we received from Troponi. As you can see in the images below, the first image is the period before lockdown, the second image is during lockdown, so we can clearly see that there was a reduction in these gas emissions. So the next step that we wanted to know is what happened with PM2.5 and PM10. As I said, in this region, PM2.5 and PM10 occur naturally also from dust emissions and sea salt, so we wanted to understand. What we are presenting today is the analysis that we have done using 10 of our quality stations, and we are comparing the data from 2020 to the data from 2016 to 2019. These data we are checking during the lockdown period, which was from 22nd of March to 26th of June. And we are ensuring that more than 75% of data availability is for each year and station to make sure that we are comparing data that can be really compared. So for PM2.5, what do we saw? We saw that there was a significantly lower concentration of PM2.5 in 2020 when we compare to the previous years. This was very important and shows that human activities have a direct impact and a direct reduction on the PM2.5 concentration. The second part of the question is, and what happened to PM10? So in PM10, we saw something very different of what we have seen with the gases and what we saw with PM2.5. As of today, we don't see a significant difference between 2020 and the previous years. Even in many of the stations, we can see that there has been an increase of concentration in 2020 compared to the previous years. So at this point of time, we reached to our colleagues from Khalifa University to try to understand from a regional perspective what happened in PM10 and how dust aerosols had an impact on the air quality in Abu Dhabi. So now I would like to hand over to my colleague, Dr. Diana, to continue the presentation.
Thanks very much, Oriol, for this clear presentation. So as Oriol has explained, the changes in PM10 during the lockdown period in 2020 were not as expected, and here we started to investigate the role of natural aerosols, such as dust aerosols and sea salt aerosols, which are known to contribute more than 40% to PM10 concentrations. So I'm showing here maps of dust aerosol optical depths and maps of dust integrated column load. These are taken from MERA2 reanalysis for the month of March to start, because the lockdown was between March and June 2020. So at the first column, I'm showing March 2020 maps. And the second column, I'm showing the reference period that we considered for the study, which considers all the months of March from 2016 to 2019. And the last column is the difference between 2020 and the reference period to see what are the changes. So for positive values, we see the yellow and red colors, and for the negative values here we will see green and blue colors. Okay, as you can see, so for the first row, which is aerosol optical depths, we can see increase in the aerosol optical depths during the lockdown period. These are the yellow patches we can see here, which are affecting actually the UAE. And also regarding the dust load in the atmospheric column, we can see also a large increase in dust activity during this month. Same goes for the month of April. where again we can see increase in dust activity and AOD increase to the north of the UAE. This was also evident in the concentration at the surface for both sea salt and dust. So here again, I'm showing the difference between the situation in 2020 and the reference period. For the month of June, again, large increase in sea salt over the Arabian Gulf, and a large increase also of dust emissions in the countries that are located to the north of the UAE and on the eastern side of the Arabian Peninsula. So after seeing these patterns in the increase in natural aerosol, we wanted to understand what was going on with the circulation during this period compared to the reference period. And here we looked at the ERA 5 reanalysis data for winds and other parameters. And here I'm showing the maps of wind speed at 925 hectopascals in shading, and the vectors are the direction of winds. So these are for the month of June, for example, and again the same plots for June on the left. In the middle is for the reference period 2016 to 2019, and the last column is for 2020 minus the reference period. One prominent feature that we can notice in these maps is the Shamal wind that is intensified during this period. And here you can see it in the yellow colors in this difference plot. So the first hint is that Shamal winds were intensified during the lockdown period. So we checked this also in the surface observations for some stations around the Arabian Gulf. Here I'm showing, for example, for the Kuwait station. So these are the wind speeds. These plots are the months here considered. So this is the lockdown period on the y-axis, and on the x-axis is the time of the day. So what you can notice is for 2020, frequent Shamal wind events represented by these red strips here and occurring during daytime especially. And here is for the reference period. You can see more calm wind during this period. And again, the difference it can show you the increase in Shamal winds intensity and frequency as well. And in addition to Shamal winds, so we noticed that also the southerlies that affect the UAE, especially during summer, with the arrival of the Indian monsoon season, were also intensified during this period. So we had stronger southerlies affecting the southern part of the Arabian Peninsula. And all this hints to higher levels of PM10, as seen here in these maps also for June. And this leads me to these conclusions, is that first we showed that during the lockdown period from March to June 2020, we had a drastic reduction in man-made pollutants in the Abu Dhabi Emirate. However, the concentration of PM10 were not decreasing as expected, and investigation into the role of natural aerosol showed that we had increase in dust emission and sea salt emissions, and those were related to stronger Shamal winds during this period, and to stronger southerlies also to the south of the UAE. So what could be the reason for this increase in the wind patterns impacting the UAE? One reason could be the intensification of the Indian summer monsoon circulation. This was already shown and published. That because of lockdown and reduction in pollutant over the South Asia area, we had acceleration of the monsoon circulation. So this still ongoing investigation and work, and we hope to conclude on it soon and publish it in collaboration with our colleagues at EAD. I would like to thank you for your attention, and hopefully you can get your feedback and questions. Thank you.